Hey everyone, we are back. Hey, so this time we're going to be looking at VSEPR Theory. What is that? Well, the word VSEPR stands as an acronym. It stood for Valence Shell Electron Pair Repulsion. That's right, electrons and electrons are both negatively charged. There is some sort of repulsion for sure between bonding electron, lone pair electrons, but which one repels more? Well, it goes by these three simple, rules or theory that lone pairs and lone pairs repel the most. Okay, so you have two lone pairs. They're going to try to get away from each other as much as possible. Lone pair and bonding pair. Now, bonding pair means those bonds, those lines, whatever you like to call them. Okay, the overlapness of orbitals. But yeah, lone pairs and these bonding pair, they repel less than lone pair and lone pair. And then if you have bonding pair and bonding pair, they repel the least. Now, what does that mean? Let's take a look at water, for example. If you notice, water are usually drawn like this. Why don't people draw water like this? What's wrong with that? Is there something wrong with that? There's really nothing wrong with that. But because, the shape of water really don't look like a line in the same plane, people look at this and say, this is not really true. Okay? The reason why we draw water like this most of the time is because these lone pairs are actually repelling each other as far as possible. Whereas these two bonding pair are repelling, but repelling less because there's more repulsion here than here, creating these two bonds to slightly bend. Okay? Hence, that's why we draw water like this. Now, you can actually prove this by using a molecular kit, but that's only if you have a molecular kit on hand. If you don't have one of those, I have a chart right here. Okay? This chart actually tells you, hey, based on your central atom, what is the shape of your molecular structure? So let's take a look at water right here. Remember what I said? Based on your central atom, what is your molecular shape? Okay, this is my central atom. If you look at this central atom, this is a 4-electron domain because there's two lone pair, two bonding pair. Okay, these are bonding pair. These are lone pair. And there's 4. That means this guy has a 4-electron domain. So we're looking at this section right here because 4-electron domain. The electron domain geometry here is tetrahedral. But is the shape tetrahedral? No, it's not. Check this out. How many bonding do you see? I see 2. How many lone pair do you see? I see 2. So you're looking at 2 bonding, 2 lone pair. 2 and 2. 2 bonding, 2 lone pair. The shape is going to be bent. The angle here is around like 105 degrees. Obviously, this will be the rest of the 360. All right? So to determine the shape of a molecular structure, you have to look at the central atom, look at how many bonds, and look at how many lone pairs. Okay? But that's only in the assumption that you did your molecular structure right and you did your octet rule to the perfect. Because if you don't do your octet rule right, you're not going to get the right structure, hence you're not going to get the right shape. So let's do some examples here. Okay, let's do some examples here. Let's go to this chart. Carbon dioxide.